Lesson 5, proportional and non-proportional relationships. How many of you remember, just a raise of hand, that's all I want. How many of you somewhat remember talking about this last year? Okay. I know in my 7th grade class, we hit it hard. Like every day I said, what are 3 ways you can tell if something's in proportion? And we'd list them. And the next day I said it again, what are 3 ways you can tell if something's in proportion? And we'd list them again. Okay. So Hannah, you remember that? Somewhat? Okay, that's good. What's that? Pretty sure we did it every single day when we have proportions. I know I did it with 7th grade every single day this year. What are 3 ways you can tell if something's in proportion? Good news, we're going to go over it again, so you're not going to forget. All right, so 3 vocab for you. 3 vocab. Proportional, constant, non-proportional. And if you want to leave a little space, I'm going to give an example of each of these things, just so you kind of have an idea. I would put bets on that too. I would have too. All right, so let me give you some examples of these things. I already need another side hand. All right, so proportional. I'm just going to give you some scenarios, and I'm going to use the same scenario throughout the whole thing. So let's say I go on my way here. I go 65 miles in 1 hour. Okay. Now, if I said that I go 130 miles in 2 hours, is this in proportion? Yes? No? Is it? What's 65 times 2? 130. See how I'm just doubled it? Because for every 1 hour, I go 65 miles. So every 2 hours, I should go 170. In 3 hours, I should do what? Probably take it somewhat, kind of, yeah. Not really today, but okay. So this is in proportion. Maybe I'll make it simpler. Let's say I go 10 miles in 1 hour. Well, in 2 hours, I should go 20 miles. That's an example of being in proportion. Okay? So let's talk about your constant. Now let's go back to this one because that seems to be easier for everybody. My constant, what's it constantly going up by? Every hour I'm constantly going up by 10. So my 10 would be my constant. Now non-proportional would be something that looks like this. So for every 10, for every 1 hour I go 10 miles. So for every 2 I go 30. This is not in proportion because it should be what? 20. It should be 20. Okay, so there's just some short, simple examples, and we'll talk about each one again. What's that? Cut in half? Sure. Okay. So my next slide is this. How can I tell if something's in proportion? Does anybody have a guess of how I can tell? Like, for example, let's say I have, are these 2 things in proportion? Yep. What's a way, let's say I didn't know. What's a way I can tell, John, if something's in proportion? Okay, so like if I times this by 3 and this by 3, so if I multiply by the same number, okay, so I can tell by multiplication. What's another way I can tell? Hannah, I can divide. If I take 1 divided by 4 and 3 divided by 12, guess what? It's going to be the same decimal. So division is another way. Anybody got another guess? Yeah? Nope. Good try. Good try. Anybody else? Lydia? Same what? Denominator? So if another way I could say I could reduce, can I reduce this? What's it going to reduce to? Okay, so reducing is a way. And there's actually one more way, and I bet you won't get it. But if I show you, yep, nope, not subtraction. What about this? I'm just going to show you something, you're going to watch this. Why didn't you just say it? Cross products. So one way I can tell is cross products. If I do 1 times 12, what do I get? 4 times 3 is, so that's another way to tell if something's in proportion. Yeah. So make sure you know these ways. For sure, no division, if I divide. For sure, no reducing. And for sure, no cross products. Multiplication, sure. So like, I'm going to go back to this. What's 4 times 4 gives me 12? So 1 times 3 is, see how I multiply both by the same and I got that, I know that's in proportion. But if I would go like this, let's say I have this, let's say 1/4 and 2/9. Well, 1 times 2 is 2, right? 4 times 2 is 8, so I know that's not in proportion. Okay, so I have to multiply by the same number, top and bottom, to get my next thing. That's what I mean by multiplication. Okay, so what's one way again? Hannah, give me one way. Reducing. Give me another way, Emma. Very good. Give me another way, Harley. Okay, give me another way. Very good. 4 ways. See? You did that all your 7th grade year and half you can't even remember. All right, so this is what's going to happen today. They're going to give you a table. Okay? They're going to give you a table. Coffee, 1 pound is $3, 2 pounds is 6, 3 is 9, 5 is 15. My question to you is if this is in proportion or not. So, there's a few different ways, like I told you. So, number one, I like to look at my first two, and you can easily do cross products like this. Okay, 1 times 6 is 6, 3 times 2 is 6. Okay, so far so good, right? But what if I go down here? Are these in proportion? 15 times 3 is 45. Yep. Okay, so, yep. And so, here's the deal. A lot of times, the first 3 might be really good, but the last one they might have off, because they're trying to trick you. So let's say I do this, and I make, let's pretend this is 20. Is this in proportion now? So yeah, another way I can look, and Harley said too, I can multiply by 3 if 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 5 times 3 is not 20, so not in proportion. Okay? So that's another way you can use multiplication. Now let's go back and say this was 15. So yeah, we're in proportion. Now my question is, what's the constant? How do you know? That's what I'm multiplying by. Yep, so that's my constant. That's what's staying consistent from pounds to dollars. I'm constantly multiplying by 3. Okay? Everybody understand? Kind of remember this from last year a little bit? Then you... Yep, that should be that. And if it's not, then you're not in proportion. Yeah, so anytime you have 1 in a number, that number should be your constant. Unless they don't, it's not in proportion. It might be, but sometimes your tables won't include 1. Sometimes they don't include 1. So let's say they don't include 1. Let's pretend this isn't even here. Still in proportion? Yes. But do I still know my constant? Sure. If I don't know my constant, if you know what's in proportion, you don't know the constant, take 6 divided by 2. 9 divided by 3. 15 divided by 5. It's still always 3. 3. Yep. Yep. All right, so let's talk about this one. Hours, distance. Not in proportion. It should what? It's going up by 20. If I do my cross products, am I in proportion? Not even close. Because 50 times 2 is? Yep. So this, what should this be? And this should be 150. Okay. Now let's say it is in proportion. Let's say these two things are here. What's my constant? 50. It's constantly going up by 50. Okay. So far, so good? All right, so a few things you need to know, and you kind of already started doing this already with me, is writing an equation for the table. You've started to actually do this already and don't even know it. All right, so one equation you have to write down is this. It's also known as direct variation. I just don't have it on here. Direct variation is the equation. That's what it's called. Yep. You've already started doing this, you just didn't know it. I don't know, because I like to screw you up. K constant. So in here case, the constant, x is the number that can change, and y is always the answer. Now let me show you how this works. Like I said, you've already been doing it, you just haven't put it on paper. Okay. So I'm going to go back to one thing we just did, and we're going to do this on what we just did, because you already told me about it already. All right, can I go to the next one? Okay, I'm going to go back to this. I'm going to go back to this. Okay, so number one, you told me is in proportion. Number two, what was the constant? Do you remember? Okay, my constant was 3. So whatever I do I multiply this by 3 to get that side, right? So let's say I wanted to find what 10 pounds of coffee is. How would I do that? 10 times 3, right? And that gives me 30. So let me explain this. Y equals kx. Let's write the equation now. You told me the constant was, and what letter is constant? K. So here's my equation for this table. Now let me show you how this works. You already just did it. If I wanted to find 10, where would 10 go in my equation? Yep. And you told me my y was 30. Remember when you have tables like this side is x and this side is y? Okay. So I just wrote an equation for this table. You guys pretty much did it for me already, but I just put it on paper. Okay. So now let's say if I wanted to find what 100 pounds of coffee was, where would I put that in my equation? My x. So 3 times 100 is, which is my, good job. You just did it. Nice work. Okay, let's do some more of those. Okay, so David mows 5 lawns. He makes $50 altogether. Okay, so first of all, let's find the constant. So 1 lawn is, okay, so let's write that down. 1 lawn is 10 bucks. Let's pretend he just does all little lawns. So for every 1 lawn, it costs me 10 bucks. So guess what my constant is? 10. So now, if I write in my equation, my y equals 10x. So let's say I want to mow 6 lawns in a day. Where's my 6 going to go? And much money am I going to make? Which is my y. Oh, and then okay, I'm sorry. I didn't even see that part. Use the equation to determine how much you would make if you mowed 13 lawns. Okay, so where would I put my 13 then? X, multiply them together. Yep. Here's the thing. If something is not in proportion, let's say I go back to this one. Pretend it's not in proportion. I cannot write an equation for it if it's not in proportion. Because what do I not have? I don't have a constant. It's not constantly going up by the same thing. So if it's not in proportion, guess what? You can't write an equation for it. First thing you need to check, am I in proportion? If it is, then you can write something. All right, let's go to this one. Sherry bakes 6 cakes. She charges $24 per cake. First of all, what's my constant? Every cake costs me $4. Guess what you're doing? You're finding the unit rate. Remember we did that a few days ago? That's where unit rate comes in here. What's the matter? What? Unit rate, you divide to find what one cake costs? You remember that. I know you do. So one cake costs $4. That is cheap. Gosh, she's cheap. Okay, so what's my equation going to be? What's my equation going to be? 4. Well, kx, but my 4 goes in for k. So now, I'm going to bake 20 cakes. How much is it going to cost me? 4 times 20 is 80 bucks. That's what it's going to cost me. This is not difficult. This is not difficult. Not at all. Emma's like, all right, one other thing they're going to have you do today is they're going to have you finish a table. Okay, so they're going to give you part of a table, and it's your job to finish it. This shouldn't be hard either, because they have to give you something in that table. They already gave you top and bottom of the first cake. Was it cake again, or cost? So if I have 2 rides, what's it going to cost? 3, 4. Okay, so what's the constant? 3, it's going to go up by 3. So what is always going to change? The cost is and my rides are going to always change. My x and my y are going to change all the time. If I'm going to write an equation, sure. If I'm going to ask you how to write an equation for this, what am I going to do to write an equation for this? Yep, y equals. Okay, so if I'm going to write 20 rides, how much is it going to cost me? $60. I use my equation to figure that out. Well, what's always changing? Well, you're right. And your cost, because I have to put something here, and if I put it here, I'm going to get something different out here. That's why my rides and my costs are always changing, but my constant, always the same. Okay? That's why it's like set in stone. That's why it's not a variable anymore. All right. What I want to do is I want to look at your homework with you before I let you get started. Okay, I want to look at that with you.